All right, this is section 5.4 extension, solving linear equations by graphing. So this takes us back to chapter 1. Obviously, when we were working with equations, we were getting the variables on one side, the constants on the other side, and that's how you would solve equations 99.9% of the time. But it is interesting to know that you can also solve a multi-step equation by graphing. So to solve a multi-step equation, like ax plus b equals cx plus d by graphing, first of all, write the two linear equations and graph them to find the x value. Remember, there's no y value here. We only want to know what does x equal. So even though there's no y value, you need to write them in slope-intercept form and think of them being written in slope-intercept form like y equals mx plus b. And then that's going to help you graph them. So before, obviously, we would have subtracted cx from both sides. We would have moved the b over to the other side, and we would have solved it that way. Today, we're going to show what it looks like to solve these multi-step equations by graphing. Now, solving them by graphing is not a very hard thing to do. Again, you just have to make sure they're written in slope-intercept form. Well, so on the left side of the equation, we've got x minus 2. So if we think of that as being y equals x minus 2, then that's written in slope-intercept form, so that's good. And on the right side of the equation, if we think of this as being y equals negative 1/2 x plus 1, then that's also written in slope-intercept form, so we're good to go there as well. So we would solve the first one, graph the first one, by plotting the y-intercept at -2. The slope is rise 1, run 1. You can see there's no coefficient there with the x, so that means it's 1. So there is our red line, so our first equation. And then for the blue equation, the second part, so this is the red part, and it says they're equal, right? They're equal, so I'm going to find out where they intersect. And then the second one here has a y-intercept of 1, and it has a slope of down 1 over 2, down 1 over 2, all the way through my graph here. So that is going to look like this. And now we have an intersection point, which is right there at the point 2, 0. But I only need to know what the x-coordinate is because it's only x's, right? So in this case, x equals 2. Now it says solve your answer using algebra, so I'll go ahead and write this over here. Using algebra, we would simply want to move, let's see if I can erase this stuff, yeah. Using algebra, we would want to move the x's over to the same side. So I've got more x's on the left side, so I would add 1/2, or I'd rather add 1/2 x than have to subtract x. So add 1/2 x to both sides, and that's going to give us 1.5 or 1.5 x's. And then I would have to add 2 to both sides to get rid of the constant value that's on the left side, and that becomes 3, right? So 1 plus 2, there we go. 1 plus 2 is 3. And then I would divide both sides by 1.5. And 3 divided by 1.5 is 2. So whether you solve it using the old-fashioned way, which is how most people solve equations, or solve it by graphing, which is what we're going to do today, either way, you get x equals 2. So again, I don't want you to panic because this is new, but it's not really that new. We're just thinking of both sides of the equations as two separate equations, right? So there was one, and then there was another one right here. Okay, so we thought of them as two separate lines, and we just found out where those lines were equal to each other, where they intersect. Now, all the ones on the 5.4 extension homework you can graph, except on 8 through 10. On 8 through 10, they don't have graphs, so I want you to solve them using algebra because I don't want you making your own graph for those. So solve 8 through 10 on tonight's homework by using algebra, just like I showed you right here the old-fashioned way. So that's good for us to remember how to do that anyways. All right, so here we have a really long multi-step equation, and we can still solve it by graphing. If you think of the left side as being an equation, I could go ahead and simplify that to, let's see, negative 2x and negative x are like terms, so negative 3x plus 4. So think of it as y equals negative 3x plus 4, and then graph negative 3x plus 4. So the y-intercept is 4, the slope is down 3 over 1, down 3 over 1, down 3 over 1, or up 3 over 1, and we have a line right here that represents that first, that left side of the equation. And then for the right side of the equation, let's go ahead and simplify that. That's going to give us, let's see, if we distribute the negative 2, that gives us 3 minus 2x. Negative 2 times 1 is negative 2. So negative 2x plus 1. And think of that as being y equals negative 2x plus 1. So we're just going to graph negative 2x plus 1 now. The y-intercept is 1. The slope is down 2 over 1, down 2 over 1, down 2 over 1. I think I found an intersection point now. Again, if you have big ideas doing this for you, software that does it, it's a lot easier to do. So as we talked about, oops, no, didn't really go through where I wanted it to. There we go. As we talked about in the last section, if these equations have the same slope, they'll either be all solutions or no solutions, but they do not have the same slope. They're close. Negative 2 is close to negative 3, so you can see that they're the same direction. One's a little bit steeper, but they do have an intersection point right here, and the x value of that intersection point is 3. So x equals 3. And just to prove it to you, we can back this up, we can erase all this stuff, and we can solve this using algebra. So if we solve it using algebra, we'll still get x equals 3. We still would have to simplify both sides of the equation, which we said this side was negative 3x plus 4, and we said this side was, let's see, negative 2x plus 1 is what we said it was. And then we would move our x's. Would you rather add 2x to both sides or add 3x to both sides? I'd rather add 3x to both sides and move our variable over to the right side. That'll keep it positive. And then we can move our constant over to the left side by subtracting 1. That gives us 3. So x equals 3. If you're thinking, well, why on earth would I not just do it this way? This was 10 times faster. That's why we solve equations that way. We don't really graph them, except for today's homework, of course. We don't really graph them as much, but it's good for us to practice. I want us to remember how to graph using slope-intercept equation anyways. So it's good for us to do. But yes, I agree that 99.999% of the time, you're going to solve any multi-step equation using algebra and getting your answer very quickly instead of having to graph. All right, that takes us to our last problem. It says plant A grows 0.5 inches per month. Plant B grows twice as fast. Write and graph two linear equations to determine the number of months x, so x is the months. I want to make sure I note that, in which the plants will be the same height, y. Okay, so I need to write two equations. So for plant A, it says it grows 0.5 inches per month. Well, that's x, right? So y, the height of the plant, height of plant A, is going to be 0.5 or 1/2 per month. 1/2 inch per month, 1/2 x. And then it says plant B grows twice as fast as that. Well, twice as fast as 1/2 would just be 1. So it grows that fast, right? 1x. That'd be twice, 1/2 times 2 is 1. And it's already, look at plant B, it is already at 9 inches. Okay, so plus 9. And for plant A, it is already at 12 inches. If I can, there we go. So I'm going to add 12. That's our starting point. Remember, the y-intercept is always our starting point. So for plant A, I plot y equals, or y-intercept there is 12. And I'm going to rise 1, and I'm going to run 2. And I'm going to rise 1, and I'm going to run 2. And that's going to give me something like this. And then for plant B, it has a y-intercept of 9, so it's a little bit smaller, but it grows faster. It grows twice as fast. So rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay, I'm thinking that are if I did this right, then it should meet somewhere here, which would be close to 5. This is months, right? So close to 5 months. Let me double check that using algebra. So if we use algebra, we set these two equations equal to each other to find out their intersection. So 1/2 plus 12, 1/2 x plus 12. When does it equal the same as x plus 9? And we can solve using algebra. We would subtract 1/2 x from each side. I need some more room. And that's going to give us, 1/2 x. That's what that would give us. And then we're going to move the constant over to the left side by subtracting 9, and that gives us 3. And then to get rid of the 1/2, you can times both sides by 2, and that's going to give us x equals 6. So that is, like I said, the issue with graphing is that it's not always entirely accurate. That should have been closer to 6. So my lines are a little bit wrong. They should be, yeah, it should be somewhere maybe going this way and then meeting here. Right there at 6 should be better. So that's why it's always good to check using algebra. So they should be the same height after 6 months. A story problem, so we have to label 6 months. And that height, you can actually see, will be around 14 or 15 inches.